Hello everyone, we are going to start in 2 minutes. Just let me set up. Okay. Hello everyone, today we are going to discuss about AtCoder's ABC contest. Okay. So this is the first problem of the contest. It just says your 1 foot is 12 inches. How many inches is A feet and B inches? Right. Okay. Okay. So in the first problem you are given with just 1 feet is equals to 12 inches. You need to find some A feet and B inches. What you can do, you can just do A into 12 plus B, right? That's an easy problem. A into 12 plus B. I guess summations right here. Okay. So for this problem, you just take the input and print A into 12 plus B. That's the direct answer for first problem. Okay, let's move to the second problem. Oh, sorry. Yeah. Okay. In this particular problem, you are given with a grid with H rows and W columns. Each square has one integer written on it, and these integers are distinct. The square at the ith row from the top and jth column from the left has integer aij written on it. Nothing, just it describes you about a grid which has H rows and W columns, and from ith row and jth column is aij. Host called the pulled out n distinct integers b1 to bn. If you find for each row how many integers called out by the host are contained in that row, what is the maximum value among these? Okay, in this problem you are given with a grid which has H rows and W columns, right? And there are some integer written in it like 1 2 3 4 5 2 3 6 7 8 5 9 12 minus 1 0, right? Some integer are written on it, and you are given with n integers b1 up to bn. Let's say for this example it is 2 3 and 6. Now what you have to do, you have to go to each of these row one by one and check how many integers from this array b resides in these row. Like for this example, 2 is present in the first row, 3 is present in the first row, but 6 is not present. So for this row, answer is 2. For this particular row, 2 is present, 3 is present, 0. Now you have to output the maximum value among this, which is 3. Alright. Now as you can see, the height and width is very small and n is very small. You can just brute force it. What you can do, make a while taking input, make a set of vector of set of integers, and put all the element of the row in this set, right? You can make an unordered set also of any row, right? After that, iterate over b, iterate over b, and check count of element present in set. That's it. You have to do just this for this problem. I'm like it. Yeah. Okay. For this, let's see the code for this problem. As you guys can see, I have taken h, w, and n as input. I made a vector of set, name as grid of h rows, and I have taken all the element as input. I have made a set for each row, input the element in the set, and push it to the grid. Then I have taken array b as input. Then this is my answer. Now I have iterated over the rows. I have checked the particular count for each row. Then I iterated over the row itself. I iterate over b itself and check how many element of the b is reside inside the row. Then I increase my count and update my answer with the maximum of answer comma count. Then you can output the answer. That's it for this problem. Is there any doubt till now? This is a pretty easy problem, right? I can't see my screen. Is there a lag in the stream? I think so. Okay, so we will move to the third problem, which is this reindeer in the sleigh 2. In this problem, there are n reindeers and one sleigh. The ith reindeer has weight wi and strength pi. For each reindeer, choose either pull the sled or ride the sled. Here, the total strength of the reindeer pulling the sled must be greater than or equals to the total weight of the reindeer riding the sled. What is the maximum number of reindeer that can ride the sled? We are given t test cases for solving each of them. Okay, now I guess there is a. Okay, it's recording. Oh, I'm getting a very high ping right now. Yeah. That's why. Okay, now for the C problem, you are given with n reindeers who has weight wi and power pi. So there are w1, w2, w3 up to wn and p1, p2, p3 up to pn. Now follow me here, right? Please. Now for each reindeer which is pulling, we can say the sum of strength of reindeers pulling must be greater than equals to sum of weight of those who are riding. Correct. So can I write this as total strength minus summation of strength of riding reindeers must be greater than summation of weight of riding. Why? Because if I subtract the total strength of riding reindeers from the total strength, I will get the strength of reindeers who are pulling, right? So I can write it as the total strength must be greater than is equals to summation of wi plus si. I just put it here. Right. Now what I can do, I can for the approach section, I will just make a cost array. Ci will it will take wi plus si. About the greedy part now, if I made light weight or slash light cost reindeers, not lightweight, they must be light cost reindeers. Light cost reindeers ride the sled, then a lot more reindeer can ride. Correct. If I make the those reindeers who are riding have less total cost or less total weight plus strength, then a lot more reindeers can ride because those reindeers who has a larger weight or greater strength will then pull the sleigh, right? So I can just make a cost array and I will iterate up to check when the condition false, right? So this is my greedy for this particular problem. Let's look at the code. Here, as you can see, what I have done, I have made an array. I have taken the input as W and P for each particular index. I have made a total strength, and I have added all the strength in that. Then I have made a cost array. I iterated over the cost array, and then I added Wi plus Pi in the cost array. Then I sorted it in ascending order so that I can get a lighter cost in the first part and a larger cost in the second part. So my current cost is 0 and my answer count of reindeers is 0. Then I have iterated over all the n, and then I check my current cost plus CI must be less than the total sum, as we have discussed. So if it is less than total sum, I appended my cost, then I increase my answer. If it is not, then I will break, because that's the greedy I have suggested. Then I can just output the answer. Right? Easy problem. Is there any doubt in this? If not, we can move ahead. Should be. I guess my stream is running a bit late. Okay, so let's move to the question number D. Testing. So in this problem, you are given with n length sequence A, which consists of A1 to AN, and a length m sequence of positive integer B from B1 to Bm. You have to find summation I equals to 1 to n, summation j is equals to 1 to m, ai minus aj mod 998244353. Okay, this is just a direct question on mathematics. If you look, you are asked to find this, correct? Now, can I break this particular term into two parts? Like modulus, let's say, modulus can be written in two forms. One is ai minus bj when bj is small. Else, I can write it as bj minus ai. Yes or no? Yeah. So let's assume um, that does order of the elements matter to me? No, because I'm doing a brute force for this. As you can see, there are two loops. I'm doing a brute force, so order of element doesn't matter for me. Now, let's assume the B array is sorted like this up to Bm. Correct. Now, if it is sorted and I take up any particular AI at the point, this is constant AI currently. Let's say well. So this well will reside somewhere here, such that all these elements are smaller than well and all these elements are larger than well. Yeah, I can write it like P1 up to some value bk is smaller than equals to well and bk plus 1. up to some value bm is larger than, well, okay. If it is like this, then for each I can find this particular k point. Then my summation will look like, my this formula will look like summation of j is equals to 1 to k ai minus bj. And for this particular part, it will be like summation of j is equals to k plus 1 up to m bj minus ai. Right? Now, if you open this summation, what is it? This is just I am doing ai minus b1 plus ai minus, or I can write it like this. For clear understanding, I can write it like ai minus p1 plus ai minus p2 plus ai minus p3 to ai minus bk. Okay. If I write it like this, then I can just take out all the ai. How many ai are there? 1, 2, 3, up to k terms. So then it will be ai into k minus bi plus, oh sorry, b1 plus b2 plus b3 up to bk. Is this just prefix of bk, prefix of b up to k? Right. I can use a prefix sum here for to calculate this in one item, just before one. Yeah. Any doubt till now? For this particular part, I'm doing for the first part. Now for the second part, I can just write it for the first part. It is ai into k minus prefix of k. And for the second part, which was summation of j is equals to k plus 1 up to m bj minus ai. Now, how will I write it? It will be written as pk plus 1 minus ai plus pk plus 2 minus ai up to bm minus ai. Now, again, you can see it is just pk plus 1 plus pk plus 2 plus pk plus 3 up to bm minus, how many times ai occurs? For this, it is m minus k times. M minus k times of ai. Now, what is this term? This is prefix of uh, b up from n minus prefix of k, right? So this is this term minus m minus k into ai, right? So now I can calculate both the summations in big O one time complexity for any ai. If I can do this, I can just iterate from 1 to 0 to n. Then for each ai, I will calculate first part and second part. Then my total will be first plus second. I will add this total, right? So this was the just this is just the D problem. I don't have to do much in this. Quite an easy problem. Is there any doubt? I can't look at my screen. It stops. Okay. Let's look at the code for this. Look, what I've done, I have taken n and m as input, both the arrays. Then I sort the B array because order doesn't matter for me. I've taken the prefix sum of B. Then I've taken the total value, which is the sum. Now for each I first found the kth value, right? I have done a upper bound of on B for search for the AI. So what is that kth index which I have to go? Then I have found the smaller part where AI is small or BI is small. That is prefix value. Then I just add a small value. I just multiply k into AI minus small. That is prefix value, right? Modulus mod. This is just because we are subtracting. I added mod. For the larger part, I have done the prefix m minus prefix k. Again, mod addition for subtraction. Then just the particular value prefix m minus prefix k minus m in minus k into ai modulus mod. This is just, then you can add both these values, first and second part, in the total, and you will get the answer. That's an easy question. For D, it's just mathematics. You have to open the inequality for this problem, and after opening the inequality you can see that at some particular point bj doesn't matter for me, so I can just sort B and find the particular index E where, oh, I'm sorry, just give me a second. Yeah, then for any particular AI, I have to find the index where AI is greater than BJ, and for after that index, every BJ is greater than AI. Then you can form two inequalities. Find, you can make the formula by splitting the summation value, and then you can just take the answer. Is this clear till here? Okay. So let's move to the ETH problem. Sort arrays. Okay. So in this problem, you are given with n plus 1 sequences A0 up to AN. AI is defined as the following. A0 is an empty sequence and AI is a sequence obtained by appending an integer yi to the end of the sequence AXI. Okay. Then find the permutation P1, P2 up to Pn that satisfy the following condition. I is equals to 1 to n minus 1 of the following holds. API is lexicographically smaller than API plus 1, and API is equals to API plus 1, and PI is less than PI plus 1. In other words, when A1, A2, AN are arranged in lexicographical order, uh, when there are multiple equal sequences, arrange those with small indices first. P is the sequence of indices that appears in that arrangement. Okay, so let me explain this problem first. In this problem, you are given with A0, A1, A2. up to n plus 1 integers, and for each, for the start, a0 is empty, and a1 can depend to any of the previous plus the y1 that is given with us. Then again a2 can depend on any previous one plus y2, and this will go on for an. It will be any previous from an plus yn, right? Now let's reframe this problem for easier explanation. Imagine you are given with a file system and there is a root folder, right? And this root folder is a0 and it is empty. Then you are given n commands because there are n plus 1, so n commands left. N commands. Each command create a new folder inside the existing one. So for example, let's take this one, 02, 01, 22 and 01. So 02, 01, 22 and 01. Right, this was the, yeah. Okay, so currently A0 is empty folder. Now A1 says I am coming from A0, which is empty currently. So in start A1 is empty and append to it, 2 to it. So then 2 is appended to it. A2 says I am currently coming from 0 folder. Okay, currently it is empty, and add 1 to it. Okay, added 1 to it. Now A3 says I am currently coming from second folder, which is 1 already. As you can see, second folder is 1. Then I append 2 to it. Then A4 says I am currently coming from 0th folder, so A0 is empty. And I will, oh, sorry, A0 is empty, and I will append 1 to it. So these will be my folders. Then you have to arrange these folders. Sorry. Okay. So you have to then arrange these folders in the lexicographical order. So what will be the lexicographical order for this? You have to go with 1 first, 1, then 1, 2, and 2. And look, both these one are equal, then you have to choose the index which is smaller. So 2, 4, then 3, and 1. So this was the output for this problem, right? So if you look at this particular problem in with respect to a file system, that you are given with some empty folder, then you are appending a new folder inside that empty folder, or you are taking a previous folder and making a new folder inside that with some value, right? So this is a structure of try or not. This gives us a explanation of try currently. So our goal is to sort this uh, from 1 to n and the lexicographical order, correct? Hmm. So we will just run a DFS over this while maintaining a current sequence, right? Any doubt? I can't even look at. Are you guys not commenting, or I can't see the comments at all? I can't see any comments. Okay, so let me draw this for you. So think like A0 is root, which is empty. A1 is parent of A0. Oh, sorry, A1's parent is A0 and it has value 10. It has value 10. It is empty. Some value 10. Then our sequence for A0 up till this is 0. Then I can also say A2 also has parent and it has scores 5. A3 also has a parent. So then A4 also has a parent 1, let's say, and it's those 2. Then A5 has a parent, let's say this, and it has value 1. Is not. So now we will look into the next group. So we will check the children of A, sorry, children of 1. These children is 4. A4 was children with value 2. And for this, A5 was children with value 1. Right. So after collecting all these, children's, what will be my values now? It will be 10 and 2 for A4 and 10 and 1. As you can see, for 1 and 3, A1 and A3, 1 should be printed before 3. But A4 and A5, which has same parent value, A5 must be printed first, then A4. A5 must be printed first, then A4. Right? So we will just run a DFS over it, check for each and every element. Then for each element, we will check the candidate, and after that, we will add it to our list. Then we will sort the list and output the answer. That's it. So let's see. So this is the code. This was the code. Still, I can't see. Okay. Okay, live stream is now syncing perfectly. All right. So what I've done here, I've just taken n as input. I've made an adjacency list of n plus 1 and it has a vector pair which consists of like uh, n plus 1 defines what is the parent and vector p1 defines the particular index and which folder it is going to, right? Value, whatever the value, particular folder value and particular folder which is going, like A5 has the value 1 and its parent was A3, then A3 tends to A5, or sorry, value 1 and A5. So this is how I am storing my adjacency list. I have run a DFS from an empty folder which is 0. Currently candidate my 0. Right. After that, what I have done here, look, I have iterated over all the current candidates, or current list, current order. Then what I have done, I have added each node to the permutation. I have added the current node to the result, so they are already sorted by index. Right. Currently it is 0, so it will add 0, but it is not equals to 0, so it will not add 0. As you can see, there is a sorting going here. So after completing the sorting of candidates, when it comes back to this DFS, then it will rearrange all the indices in the sorted form and will be appended to the permutation. Okay. Then I have connected all the children. I have run over all the folders. You can say it folders, which is the current sequence. Then I have iterated of the current sequence. I have checked the adjacency of that particular folder, check for each children, and then I have added that children to my candidate array. Right? If candidate array is empty, then I can just return it. Else, I can sort the whole array, candidate array. So I will get the lexicographically smaller candidates first. Then uh, I need to group the candidates. So I have output the size. So I have iterated over the candidate array. J is equals to I. Then y is equals to cand I dot first. Y is the value, current value, which each particular folder holds. Then what is the next step for this particular uh, children? Then j is less than size. Candidate j dot first, which means next folder which is coming. Like for 10, there are two folders that were coming. For 10, there were two folders, which is 2 and 1. So I will check for these. If it is equals to y, then I can just, if 10 is equals to 10, then I can just put next, in the next permutation, I can put my the folder name, which is 1 and 2. I have increased the j plus plus. Then 1 and 2 will go into the DFS and it will be added to the permutation again. Then I have updated my I equals to j. Then I can just output my permutation. Is this clear till now? Is there any doubt in this particular problem or not? If, then we will move forward. No? Can someone just let me know in the chat that is everything fine from my side? Okay, so I'm moving to the next problem as I'm getting no response today. Okay. So this is the F problem and today's last problem. There are n Christmas trees on a two-dimensional place. The ith Christmas tree is located at the coordinate xi, yi. You are given with q queries. Process each of the queries in order. Each query is one of the following. Type 1 query given in the form 1 I x y. Change the coordinate of the ith Christmas tree to x comma y. Type 2 query is 2 comma L R x y. Output the Manhattan distance from the coordinate xy to the farthest Christmas tree along L plus 1 up to R, which means, okay, so this is the problem in which you are given with a two-dimensional plane and there are some coordinates like this. These defines, let's see, so bi-weekly contest. Yeah, Liquid is down currently. I'm also getting messages about that. You can just keep trying. It will open in 1 or 2 minutes. Yeah, it will open in 1 or 2 minutes, or the bi-weekly will then get undated. So there are some Christmas trees on coordinate like say x1 y1, x2 y2, x3 y3, x4 y4, x5 y5, x6 y6, and x7 y7. Now you have given with two types of queries. First type of query is this, and second type of query is this. Okay, in the first type of query, what you can do, you will choose the ith uh, Christmas tree. Let's say queries like this: 1, 4, 8, and 9. Then you will choose the fourth Christmas tree, which is x4, y4. Then you will update x comma y to 8 comma 9. So which means this particular point will move to some other point, 8 comma 9. Correct? So this particular index will go to 8 comma 9. And the second type of query says you have to find Manhattan distance between x comma y. Let's say second query x comma y is 0 comma 0 and LR is 3 comma 5 for the second type of query. Then you have to find from 3, this is x3 y3, this is x4 y4 earlier, and x5 y5. You have to find the maximum Manhattan distance from 0 comma 0 from all these 3 points. So currently it is x5 y5, so you can just take Manhattan distance of x5 minus x plus y5 minus y. For this particular, this is the answer. Correct. For this particular example. Correct. Everyone understood till now. Now, let's understand one thing for this problem. Give me a second. Okay. So, for the first query, I just need to update. And for the second query, I have to find the Manhattan distance of some particular, let's say this is my xi minus x is constant plus yi minus y. Y is constant. Now x and y is constant for this, and xi and yi can be any term. I need to find the maximum of all of this. So I am going to open this inequality. So it will be open like x minus xi plus yi minus. Sorry. This was small x. Yi minus y. Second one will be xi minus x plus y minus yi. Third will be x minus xi, capital Xi. This is capital yi minus y. Fourth one will be x minus capital Xi plus y minus capital yi. Right. These, if I open this inequality for Manhattan distance, I will get these four terms. Correct. Okay. Then can I rearrange these? I can rearrange it like xi plus yi minus x plus y. This is a constant. Keep it in mind. Then xi minus yi minus x minus y. This is a constant. Then let's say minus xi plus yi plus x minus y. This is the constant. And minus xi minus yi plus x plus y. This is the constant. Now, if you ignore these constant terms because you can't change them, you have to maximize all of these for any particular index I, because x and y are fixed for each query. So we need to maximize this. Maximize what? You have to maximize xi plus yi, xi minus yi, minus xi plus yi, and minus xi minus y. You have to maximize all of these. Now, what will be your solution for it? Now, what is the basic intuition or basic, click in the mind when you hear about a range and updates? Is that segmentary? When you hit something like range and updates, you have to do, you have to find something in the particular range, and you have to do updates on particular values, and you can't do in big O and square. You do segmentary. Yeah, yes or no? Okay. So we need to find the range maximum query for the segmentary. This time by structure of the segmentary node will consist of these four values. For each particular node, x and y, I will store these particular values. Let's say v1, v2, v3, and v4. There are four nodes, and these are the four values for each node. While making the segmentary, I will keep this in mind. Then just you don't have to do anything. You will just go to update. When you ask for type 1 query, you will update your segmentary with new x comma y. Then the node will be break again, so you will merge the new node, and the segmentary will be update again. And for the second part, you will just query of that l comma r about the maximum out of all all the values indexes, all the indices with all four nodes. You will check the maximum out of all the indices of these all four nodes. Then you can just directly get the answer. Nothing very complex in this. Just you have to implement the segmentary directly. In this, I guess the part of doing inequality was this inequality part makes it more complex. But you have to just directly implement segmentary. So if you get this, that you can split it like xi plus yi minus x plus y, and these are constant, so you have to look for these. Then you can just directly understand why segmentary will be used, because you are going over indices and there are four points. You will make a node of four indices, four values. Clear? Okay. So let's look directly into the code, because segmentary code is fixed for most of the problems. I will just have a little update. I will explain. Um, Result, my submission. Okay. Okay. So this is my segmentary. As you can see, I have made a structure of node consisting of four values. Initially, I have given it -218 for a large negative. Then I made a vector pair of trees and a segmentary. Now this is merging of nodes. You know, for each when you are updating, you will merge it. Now void build function, you build the node. If start equals to end, you get the first and second tree xy. Then all these values, as I have said, x plus y, x minus y, minus x plus y, minus x minus y, in the each of the segmentary value. Correct. Else, if it this is the basic segmentary, and you will take the mid, you will go to 2 into node, which is the left children, this is the right children. Then segmentary is equals to merge of both of the segment, both of the trees. Then this is the void update, in which you will get x comma y. So if you are at the start equal to end, you are at the particular node, you will just update it with the new values. Else, this is again the basic common part in all the segmentary, you will take the mid. If you are inside the particular segment start and end, you will update or start up to mid. Else you will update mid to end. Then you will again merge the tree. Now this is the query section. You are given with query LNR. If it is a invalid query, you will just return an empty node which is minus infinity. If you are inside the particular range, then you will return the segmentary. Else you will take the mid, then again the left children, right children, and merge to both p1 and p2. Correct. Now after that, in the main solve section, I have taken input. I have resized my segmentaries. You have to resize this again and again to make it empty. I hope you understand this. Now I have taken the input x and y. I have built the segmentary. Then I have taken queries. I have iterated over queries. I have taken the type as input. If type is 1, then index and xy as input. Then I will update my trees I at xi, and I will update the particular segmentary also. I have updated the particular this trees defines that Christmas tree. So I will updated the ith Christmas tree as xy, and then I will update my segmentary. Else I have gotten a range query, then I will take lnr xy as input. My node will be my result node will be query of nlr answer is equals to 280. Then I will take the answer of all these particular values. As you can see, I have taken vi minus x. This is the Manhattan distance because x and y is constant. So what I wrote here, this thing, but the whole this thing is right here. This v0 contains of x minus y, sorry, x plus y, x I plus yi, then subtract with x plus y. Then you can take the answer maximum from all of them and just print the answer. So that's it for the F problem. Is there any doubt till now? Is there any doubt in this problem? This is also an easy problem and quite intuitive. No one? If not, we can just sum up our post-contest discussion now. Is there any doubt you can just clarify now? Most of you are doing lead code contest, I guess. Okay, so let's wrap up this post-content discussion. I hope you were able to solve a lot of questions in this, and thank you for joining. Bye bye.